Okay, if you can recall stuff from last week Wednesday, I know it feels like a long time ago, but last week Wednesday we were covering confidence intervals, okay? And so today I'm going to just cover more on confidence intervals. Okay, and we said and we covered confidence intervals for the population proportion P. And we said, you know, based on a sample of data, okay, we can say, you know, we are, you know, blank, and I think we left off with something like 95% confident that the population proportion P is between P hat minus, and then I'm going to put in I'm going to put a box around this 1.96, okay? 1.96 times the square root of P hat times 1 minus P hat over n, and so it's between that number and P hat plus 1.96 times the square root of P hat times 1 minus P hat over n. Okay. I hope this looks familiar from Wednesday. Okay. And this number 1.96, this corresponds to the value we use when we create a 95% confidence interval. Okay. And so this number in the box, this is called our critical value z star. Okay, so perhaps I can rewrite these two equations to just P hat plus or minus z star times the square root of P hat times 1 minus P hat over n. Okay, and yes, so the z stars, let me just give you, these are kind of z star values that we need to know. Okay, and depending on our confidence level, we have different z stars. Okay, so confidence level and the corresponding z star. So if we want to be 95% confident, our z star is 1.96. If we want to be 99% confident, our z star is 2.58. If we want to be 90% confident, then we can have 1.645, and then at 80% confidence, we're down at 1.28. Okay? And so what we notice is that lower levels of confidence require smaller z stars, and higher levels of confidence require larger z stars. Okay? So we can have smaller z stars, or smaller critical values, if we are willing to have a lower confidence level. Okay. And you know, the reason why we might want to have a smaller z star, a smaller critical value allows you to have a more narrow interval. Okay, and a more narrow interval is generally more preferred because it gives you a more precise range of values that you can work with. Okay, and when you have but the trade-off again is that you're going to have less confidence in that that interval that you are providing. So you can give a real narrow interval, but you can't be super confident that that the population proportion P is within that interval. And on the other hand, if you want to be very confident that your interval contains the population proportion P, you've got to create a really wide interval. Okay, so we can have a smaller z star. So smaller z star means a more narrow interval, generally a desired quality. Smaller critical value means narrower interval. And I can't recall if I did the, did I pretend to flip a coin on Wednesday? No. Okay. Good. Well, I'm going to pretend to flip a coin today, but that will come in a moment here. All right. Okay. So, okay, I'm going to flip the slide, and I'm going to put up we're going to have a true/false clicker question. It's a tough one. All right. Let's okay. So let's say we make a let's say we made a confidence interval, okay? Okay, and then our statement, our interpretation is I am 95% confident that the population proportion, what am I talking about here? The population proportion of, I don't know, M&M candies that are blue, because this is an important question to be answered. Is between, I don't know, 0.127 and 0.233. Okay, so I'm 95% confident that, you know, the proportion of M&Ms that are blue, somewhere between 12.7% and 23.3%. Okay, 95% confident. Okay, here's your clicker question. True, false. Okay, so by the way, this part is true, the top part. Okay, and now your question is true, false. There is a 95% probability that the population proportion of M&Ms that are blue is between 0.127 and 0.233. Okay. All right. This seems almost too easy. Now you're not so sure. Okay. Well, go ahead and talk with your neighbor about what you think your answer, what the answer should be. Okay. So true, we'll say is A, and B will be false. Okay. On the clicker thing. Okay.
like confidence doesn't use that like for guessing.
Explain what I don't understand.
Yeah, I remember this.
All right, you guys are discussing true, false. There's a 95%. So we've established that we're 95% confident that the population proportion of M&M candies is between 0.127 and 0.233. Does that mean there's a 95% probability that the population proportion is between 0.127 and 0.233? That's the question. Okay, I'm going to go ahead and click stop here. So if you haven't clicked your buttons, click your buttons.
It's 99% of the hypothetical.
Okay, all right. Let's take a look and discuss our answer here. Okay. All right. The correct answer is false. Okay. All right. Let's discuss why. Okay. Now a lot of you probably clicked false because you felt like this has got to be a trick question or something. You're not quite sure why. Okay. Well, let me explain. All right. And this is where I'm going to pretend to flip a coin. I didn't do this already? Okay. Okay. All right. So pretend I've got a coin here. All right. One side is, I've got a quarter. One side is heads, the other side is tails. I'm going to ask you a question. I'm going to say, I'm going to flip this coin. What's the probability that the coin will land heads? And you tell me 0.5, right? The probability that the coin lands heads when I flip the coin is 0.5. Okay, no argument there. I'm flipping it. Okay, and it's landed. All right. All right, so it's landed. It's right here, okay? And I'm going to ask you, what is the probability that the coin has landed heads? And what do you guys tell me? Okay, so you're confused as what I'm talking about. You say 0.5 still. Okay, now I look at the coin and I cover it back up and I look out back at you and then I ask you the same question. What is the probability that the coin has landed heads?
It's already happened now.
Okay. All right. And then so now you guys are still confused. Some of you are saying it's already happened. Some of you are saying it's 0.5. Okay, and the answer is the last two questions were trick questions, okay? According to the way we've defined probability, is that yes, prior to my flipping of the coin, there was a 50% probability or 0.5 chance that it would land heads, okay? However, once it has landed, once it landed, there's no probability associated with it anymore. It is a done deal, okay? It either landed heads or it landed tails. You don't know how it landed. However, it no longer makes sense to ask about probability, okay? Because there's no uncertainty in the event, okay? You don't know what it is, so all you can say is, I am 50% confident that the coin landed heads, or I'm 50% confident that the coin landed tails, or something like that. However, it does not make sense to say there's a 50% probability that the coin landed heads, because the truth is it either landed heads or it did not land heads. There's no uncertainty there, okay? And the same idea holds here, is that the proportion of M&Ms in the population, we don't know exactly what it is, but there's no uncertainty in it. If we could freeze time right now and count all of the M&Ms in the world and count all of them that are blue, we could get an exact proportion of blue M&Ms in the population. Okay, I mean that would be a silly waste of energy to work on, but there's no uncertainty as far as this population proportion. Okay, so I'm going to write that. So there's no uncertainty in the population proportion. It is a fixed quantity.
Oh, that's true, yeah. That's awesome.
Fixed, and I'll say, but unknown quantity. Okay, and so because there's no uncertainty, we cannot talk about probability. Okay, because it's unknown, we talk about confidence. Okay, and so that's why we cannot say that there's a 95% probability that the population proportion of M&Ms is between 0.127 and 0.233. Yeah, either it is in that interval or it's not. Okay. There's no uncertainty associated there. It's just it's either in that interval or not. We don't know, but we're 95% confident that it is. Okay. Is that all right? Okay. We'll ask. Okay, so let's say I don't know. I'm do another confidence interval, and I don't know. So we'll say we go to some college campus. Okay, and then somehow we get a random sample. Get a true random sample. Of, I don't know, 550 students. And then we'll say that 350 of those surveyed own a vehicle. Okay, so we'll, okay, so we make let's say we make a 90% confidence interval for the proportion of students at the university or students at the college who own a vehicle. Okay, all right, so I'll go ahead and I'll just do this quickly for us. So our p hat here is going to be 350 divided by 550, and let me pull out my calculator. 350 divided by 550 is 0.63636. Okay. All right, and then and so I'm going to have p hat plus or minus z star times p hat times 1 minus p hat over n. Okay, so for 90% confidence, my z star is going to be 1.645. All right, so I have 0.636. I'm going to just round off to 0.6364 plus or minus 1.645. Divided by n, which is 550. Okay, so I get 0.6364 plus or minus 1.645, and I'll punch this into my calculator, the square root of 0.6364 times 1 minus 0.6364 divided by 550, 0.0205. And multiply this by 1.645. Okay, and I get 0.0337. Okay. 0.6364 plus or minus 0.0337. And so that gives me 0.6364 minus 0.0337, 0.6027, 2, and on the upper side, we'll do the plus, 0.6701. Okay, so I say something along the lines of, I am 90% confident that the proportion of college students who own a vehicle is between, I should say, college students at this campus who own a vehicle is between 0.6027 and 0.6701. Okay, that's great. Let's ask some questions about the types of interpretations we can make from such a confidence interval. Okay, so I'm going to just go ahead and copy this onto the next slide. Okay, and so this is the confidence interval that we have created. Okay, and so here's a question. So we can say, do we have evidence that the proportion that the proportion who own a vehicle, and when I say proportion who own a vehicle, I mean proportion of college students at the campus, okay? But I just don't feel like writing the entire phrase out. Do we have evidence that the proportion who own a vehicle is not 0.63? Do we have evidence that the proportion who own a vehicle is not 63%? What do you guys think? We'll turn this into a we're not. I guess we're gonna get into the land of technicalities, aren't we? Yeah. Well, just at face value, do we have evidence? Do we have evidence that the proportion who own a vehicle? Or I guess we can change it to: are we confident? I mean, we can. They're Do we have evidence? Are we confident? If that makes you feel better, okay? Do we have evidence, or are we confident that the proportion who own a vehicle is not 0.63?
I'm not confident. Wait, that changes my answer.
That changes your answer? It shouldn't change your answer.
Now I'm confused.
Now you're confused. Okay, well, good. This is a good question then, to ask, because.
No, it doesn't change my answer. No, we're not confident. It's not.
So many no's.
Okay, I'm gonna click stop here pretty soon. Okay, so just decide on an answer. Decide on an answer.
I have like a bad
Okay, I'm gonna click stop here. Okay, is this the? Did we get the same results last time? Okay, 121, 120. Okay, it's like very similar. Okay, the answer is no. The answer is no. All right. Okay, so if somebody, your resulting interval went from, let's just for simplicity's sake, let's say it went from 60 to 67%. Okay, we're gonna just round off for simplicity, so I don't have to keep saying 60.27 and 67.01%. So I say, I'm 90% confident that the proportion is of those who own a vehicle is between 60 and 67%. Okay, and I'm now asking, do we have evidence that the proportion who own a vehicle is not 63%? Or I could similarly ask the same question: are we confident that the proportion who own a vehicle is not 63%? Okay, and so the answer to this part, the way we answer this is we say, well, you know what, 60.63 falls inside our confidence interval. Okay, and what that means is that anything inside our confidence interval we're going to deem as a, quote, plausible value of P. Okay, so we say that anything inside, say that any value inside our confidence interval is a plausible value of P. Okay, so 0.63 is a plausible value of P. So that means we do not have evidence that it's not 0.63. Okay. Now we have to be careful with all of these double negatives, and I have to phrase it exactly that way. Okay. So I have to say, 0.63 is a plausible value of P, and I have to say, I do not have evidence that P is not 0.63. Okay. All right. If somebody came and asked me a similar sounding and probably a more concise question that I would have to answer, a little bit differently. If somebody says, do we have evidence or, / are we confident that the proportion P is 0.63? Okay. Do we have evidence that the proportion P is 0.63? Our answer here is also no. Okay, we have to say no. All right. Okay, even though I say I do not have evidence that P is not 0.63, that's not the same thing as saying I have evidence that P is 0.63. Yeah, we have a question.
When they say are we confident, are we confident, does that mean are we 100% confident? Like we're certain? Sorry.
It doesn't, well, okay, well, certainly we're not certain, we're not never certain, but we can't even say I'm 90% confident that P is 0.63, okay? P falls inside my interval, but I am 0% confident that P is 0.63, okay? Because when I say, do we have evidence that the proportion P is 0.63, I'm effectively saying, is the proportion P exactly 0.63? Okay, is it exactly 63%? Meaning, like, is it exactly 0.630000 off to infinite number of zeros trailing that 3? And the answer is no. that will only happen if the proportion is if the population is a nice multiple of 100 and the number of people or number of proportion who own a vehicle is an exact multiple of 63 or something. So yeah, to say that I don't have evidence that it's not 0.63 does not mean the same thing as I have evidence that it is 0.63. We will never be able to say, and this is just kind of how it works in statistics, is we will never be able to say that the population proportion P is an exact value based on a sample. The only way you can say that the population proportion P is an exact value is by observing the entire population proportion and calculating, observing the entire population and calculating the exact population proportion P. Okay, and then there's no question then. But that's the only way you can get an exact value for the population proportion P. So the only way we can answer a question about the exact value of P is to measure the population proportion P exactly. Okay, which defeats the whole point of trying to use a sample of statistics to answer questions about the population. Okay, let's keep, I'm going to just do a few more of these kind of interpretations based on the confidence interval, because this is, I think this is the important part of confidence intervals, okay? Like, once I give you that formula, for confidence intervals, it's not too terrible to just plug in numbers and get it. But then understanding the kinds of conclusions we can make, that's important. Okay. So we said, do we have evidence that it's not 0.63? Okay. On the other hand, we can say, somebody could ask, do we have evidence that P is not 0.675? Okay. Okay, and the answer here is yes. Okay? Yes, I'll say 0.675 falls outside of my interval. Okay, so therefore 0.675 is not a plausible value. And I can say, I have evidence that P is not 0.675, okay? All right, so I can say that. All right, is that okay? All right, and then some of you guys might object, but yeah, let's.
So what, when you say something's plausible, that's defined by the confidence interval you chose?
Yes, exactly. So I was gonna show you that. Okay, so this was a 90% confidence interval, right? What if I made a 95% confidence interval? Okay. What changes when I go from a 90% to a 95% confidence interval? The only thing that changes, if I flip back a couple slides, the only thing that changes is that this number 1.645, this Z star, will become 1.96. Okay, everything else, my p hat's the same, my p hat times 1 minus p hat over n, that value is the same. The only thing that changes is this 1.645 goes to 1.96. Okay. So, let me just say, what if I made a 95% confidence interval? Okay, so what would end up happening is I would get 0.6364 plus or minus, instead of 1.645, I would get 1.96 times 0.0205, okay? And this results in, I get 0.595 to 0.677, okay? All right, and then, so now if I ask this exact same question here, do we have evidence that P is not 0.675, what happens to my answer? Okay, so my resulting confidence interval is now 0.595 to 0.677, and now I'm asking the exact same question, do we have evidence that P is not 0.675? And now my answer is, oh no, 0.675 is inside the interval, okay? And then I would say, I do not have evidence that it's not 0.675. Now this seems terrible. We're using the exact same data and the exact same question. Do we have evidence that P is not 0.675? And we seem to be coming to two totally opposite conclusions. Now, how can this be? Well, what's going on here is that we are using different levels of confidence to answer this question, okay? And so right here when I say, yes, 0.675 falls outside of my interval, you know, I have evidence that P is not 0.675, there should be a little star that says I'm only 90% confident in my answer, okay? I am 90% confident in my answer here, okay? Okay. If someone says, well, I'm not happy with 90% confident, okay? I want you to be 95% confident in your answer. Well, then you say, okay, well, if you want me to be that confident, then no, I'm not sure anymore, okay? And that's what's going on. If you want to be even more confident in your answers, then your intervals get wider, and then you can no longer kind of dispute certain things, right? If the bar for making a conclusion gets raised, then you might have a harder time making certain conclusions. Okay, so I do not have evidence that it is not 0.675, and that is because I'm trying, I'm more confident in my answer. Okay, we have to give a more wishy-washy answer if we're going to be more confident in our responses. Okay. All right.
Well,